In a world where weather patterns intensify, carbon emissions increase, pollution cripples ecosystems, we have greater reason to turn to nature as a source of inspiration for our designs. Aguahoja is turning over a new leaf. I'm Paloma, a high school student dedicated to improving our relationship with the natural world. I've conducted research on stormwater management in the past and am currently planning on a new project based on the principles of biomimicry. I came across this particular project after watching a TED Talk by MIT professor Neri Oxman. I was completely enthralled by the idea of looking to nature's designs as inspiration. Today I'll be discussing the inspiration behind Aguahoja, the process taken to carry out this project, as well as the project's future applications in society. Aguahoja is a brainchild of Neri Oxman, MIT professor and creator of the MIT Mediated Matter Group. Oxman is widely considered the pioneer of material ecology, a field that studies how technology and nature intersect. Her project is an experiment with nature. It tests the limits of the organic world in a display of architectural splendor. The main motive for this project was to thwart the effects of plastic pollution. With over 380 million tons of plastic produced a year and less than 9% of it being reused, there's been greater reason to investigate materials to serve as alternatives to our destructive plastics. Oxman and her team's ultimate goal was to create an organic biodegradable structure capable of adapting to the environment. Chitin, cellulose, and pectin are some of the plant's most abundant biopolymers. By using widely available biological materials, Aguahoja does not impose a significant carbon footprint on the environment, a model for future engineering projects. Oxman's structure is made up solely of these abundant biopolymers. After collecting these materials from 5,740 fallen leaves, 6,500 apple skins, and 3,135 shrimp shells, its intricate designs were 3D printed by a robot. The structure can also capture CO2 emissions, as there are microorganisms embedded in some of the air pockets that formed during the structure's production. This ultimately further reduces the structure's carbon footprint. The research team created and tested several layers for the structure. The group tested many characteristics, including dissociation rate, hydration-guided shape formation, and physical property distributions. The team was left with several quote-unquote artifacts of these trials, which continued to grow and adapt even after they were no longer being tested on. After this rigorous testing, the team produced a biocomposite, or a layered structure composed of biological materials. Oxman and her team produced a 5-meter tall biocompatible structure. It has a hierarchical network of patterns for stability, as well as several shell and skin-like elements, giving the structure strength and rigidity. The structure has a generative surface, meaning its surface patterns react to changing heat and humidity levels in the environment. The structure becomes rigid with the evaporation of water, a feat that is especially useful as climate change continues to impact weather patterns. Aguahoja holds considerable promise for the structural engineering, architecture, and environmental restoration that will occur in the future. Biomaterials have been used to create architectural structures in the past, but Oxman's team was able to scale up their final product more than any other group had. As Oxman's project indicates, biopolymers can serve as an effective medium for architectural structures. These construction materials are plentiful on this planet and biodegrade efficiently. Oxman's project serves as an inspiration for future structural material and engineering projects, as it can help us coexist more effectively with the natural world. If the tenets this project promotes are applied in more respects, biopolymers and generative surfaces will serve as a foundation for a healthier future. I thank you for taking the time to listen to my presentation. If you have any questions, please feel free to reach out to me using this email. Thank you again.